Okay, so we've talked about the function of a log, what it looks like, and the purpose it serves, being the inverse to the exponential. We need to make sure that we are constantly thinking about the fact that logs are really just exponents. Now, that means that all of those properties that exponents had, there were tons of them. Those properties that we use to manipulate all of those exponents somehow should also have a means of allowing us to manipulate our logarithms, because if logs are exponents and exponents have properties that let us move things around, then logs can be moved around with some properties. We're going to use some variables here for the properties, for the setup of them, m, n, and b. B is going to be our base, m and n are going to be the moving parts. So b has that extra restriction. Not only is it positive, but it's not equal to 1. First property, our product property. Now, product means that we're multiplying things. And if we remember from exponents, when we multiplied two things with the same base, we added our exponents. That same property is really what's being applied here. We're multiplying m and n, which means that we can separate it into two exponents that have been added together. Recognizing that the property is talking about the product that is part of the argument of the log. It's the piece that's buried on the inside. Quotient property. Everybody loves division, right? Who doesn't love fractions? So quotient property is about identifying the fact that we see something being divided in our argument. And now when we dealt with our exponents, division, when we had the same base, resulted in us subtracting our exponents. So division, as part of the argument here, can be rewritten as subtraction of two exponents of two log expressions. Our power property. Power property, well, anytime we raised anything to the power, especially when we raised an exponent to another power, it became multiplication. So if I have the log base b of m to the n, I have that extra power on m, I can write it as the product of that power and the exponent. These are bidirectional. We can either go from having that single term and expanding it out, or we can go from having a number of terms and we can condense them down into fewer. Ideally one, maybe even something we can evaluate, but fewer. So when we're asked to simplify, we're really being asked to condense the expressions. Condensing meaning we go from multiple expressions down to as few as possible, hopefully one, maybe something we can evaluate. So we start with something like the log base 4 of 32 minus the log base 4 of 16. Well, seeing as I can go in both directions, division and subtraction were paired, multiplication and addition were paired. And when I see constants out front, they can become exponents within the log expression. So I see subtraction, which means it can be rewritten as division. So the log base 4 of 32 over 16, paying very close attention to the fact that it is the argument that changes. We do not just divide the two log expressions. The argument changes. It gets condensed to within one log expression, which 32 over 16 is 2, and because we've been practicing evaluating, we know that 4 to some power is equal to 2. Well, it's the 1/2 power because that's the equivalent of square root. If we have 3 log base 2 of x plus the log base 2 of y, these are both base 2, I see addition, that means I can multiply. I also see the 3 being multiplied by the exponent, which means it could also be written as a power within the argument. So the log base 2 of x cubed, and then I multiply the two things, again, condensing them into one argument, one log expression, not the product of the two logs. If I'm asked to expand, that means I'm asked to take one singular log expression and use those properties the way we wrote them, left to right, putting them into multiple pieces, not the cleanest, but it's possible to rewrite them that way, and it done correctly, it's equivalent. So I see division, which means I should be thinking subtraction. It's the log of 6x minus the log of z squared. I also see that exponent. That exponent says the power property can be applied. So the log of 6x minus 2 times the log of z. What if what I see is division? Remember, we pair multiplication with addition, we pair division with subtraction. So I can write this as 2 log expressions being subtracted. The log base 3 of z to the 5th, that to the 5th means that I can rewrite it as 5 times the log base 3 of z. The log base 3 of 243, that's something I can evaluate. The log base 3 of 243, well, 3 to the 5th power is 243, so it's 5 log base 3 of z minus 5. Now, in the calculator, we have one more property we need to talk about. The calculator is set up to handle log base 10, or eventually we'll see that log base e is an option. If I'm asked to evaluate something like the log base 34, or the log base 17, or the log base 57, the calculator can't readily handle that unless I know how to manipulate the expression. We use something called the change of base formula, which allows us to take any log expression and rewrite it as a different expression, still equivalent, but with any base we choose. So the variables we need here. Still got m, still got b, c. C is going to be the base we choose. It can be anything. It's a choice. There is no guarantees on what it will be for any given problem. You get to choose, which I know a lot of you don't appreciate. But the log base b of m can be rewritten as the log base c of m divided by the log base c of b. C being whatever number we choose to use. That choice is important. If I'm asked to evaluate the log base 25 of 125, there's 2 ways I can go. I can start by recognizing that 25 and 125 are both powers of 5. Now, in recognizing that, that means the choice is that I'm going to choose a common base between the 2 values that I'm working with, that common base being 5. That's the C in our formula. So I will rewrite this as the log base 5 of 125 divided by the log base 5 of 25. Each of those can be evaluated. The log base 5 of 125 happens to be 3 because 5 to the 3rd power is 125, and the log base 5 of 25 is 2 because 5 to the 2nd power is 25. So all said and done, that means that the log base 25 of 125 is actually 3 over 2. That's all well and good when we recognize a common base, when we can work with things that we've seen before. Now, what if we don't? Well, this is why the calculator is handy. The calculator functions on either log base 10 or log base e. Well, if it only works for log base 10, then my chosen base should be 10. There's no reason to avoid it. It'll make things simpler. So the log base 25 of 125 can be rewritten as just log 125 divided by log 25. At which point I actually have to go ahead and start that whole button pressing process. Maybe I'm good at it, maybe I'm not, but either way it's got to happen. All said and done, I will arrive at that same 1.5 value. Those are our properties for logs.